To perform a gel electrophoresis, proteins need to be first purified away for further analysis. There are multiple ways to purify proteins, but it is essential to have a pure sample to continue electrophoresis so that an accurate molecular weight can be attained from the gel. Shown here, 3 proteins were separated from each other and their impurities were removed.
Purified proteins are then denatured with a substance called sodium dodecyl sulfate. Sodium dodecyl sulfate features a sulfate functional group on the end of a 12-carbon chain. The sulfate group denatures all proteins present, so now every protein has the same negative charge and wet spaghetti noodle shape. Now, the only difference in our proteins is the length of the peptide chain.
Next, the purified SDS-treated proteins are loaded into separate lanes on a polyacrylamide gel. Usually a benchmark ladder is used to compare protein samples to known molecular weights. Shown here, the purified proteins are loaded onto the negative electrode of the gel.
Finally, proteins are separated on a polyacrylamide gel. As voltage is applied, the negatively charged SDS denatured proteins run to the positive electrode. Because the proteins only differ in the polypeptide length, the shorter polypeptides travel through the polyacrylamide gel with more ease. Thus, the smaller proteins travel farther down the gel than the larger proteins. Shown here is an example of a polyacrylamide gel. In lane 1 and 4 are molecular weight ladders. Lane 2 shows an unpurified protein, while lanes 3 and 5 show purified proteins. The smallest peptides travel farthest down the gel, having the lowest molecular weight. The purified proteins show a single band, while the unpurified proteins have multiple bands present. Other than SDS Page, there exist other techniques of electrophoresis, including isoelectric focusing, which is an experimental determination of pI, and 2D electrophoresis, which is similar to SDS Page but separates proteins by size and pI.